So in this problem, we need to determine the equation of a parabola with focus at 1, 1, and the equation of the directrix is given to us. Let us begin. So let's try to understand the problem graphically first. We'll begin by considering a straight line having the equation x plus y plus 1 equals to 0. So this is the directrix line. Now, what we'll do, we'll draw a line which is going to be perpendicular to the directrix line, and as line is referred to as the axis of symmetry. Now on the axis of symmetry, we're going to consider a point F. F has the coordinates 1, 1. This F point is going to be referred to as the focus of the parabola. Now, using these two information, the equation of the directrix line and the coordinates of the focus, we need to determine the equation of the parabola. To begin with, we will consider a point P, which has the coordinates h, k. And this point P is going to be the locus of the parabola. Now what we'll do, we'll join point P and point F, and then we're going to drop a perpendicular from point P on the directrix line. And let's say it meets the directrix at point M. Now we know for a fact that for a parabola, the position of the point P is such that its distance from the focus is always equals to the perpendicular distance from the directrix line. That means PF will be equals to PM. Now we can easily find out the length PF. All you have to do is use the distance formula. We'll take the square root. Underneath the square root, we'll take the difference of the x coordinate. So that's h minus 1 whole squared. And then add it to the difference of the y coordinate. So that's k minus 1 whole squared. This will be equals to PM. Now PM is the perpendicular distance of the point P from the directrix. We have a formula for obtaining the perpendicular distance of a point from a straight line. So let's quickly go through the formula that we'll be using in this case. Let's say we have a point P with the coordinates x1, y1. And then we have a straight line with the equation ax plus by plus c equals to 0. Now if we drop a perpendicular from this point P on the straight line, let's say it meets at the point M, then the perpendicular distance PM will be given by absolute value of ax1 plus by1 plus c divided by the square root of a squared plus b squared. What we have done is we have taken the coefficient of x, which is a, and multiply it with the x coordinate of point P, added to coefficient of y, and multiply it to the y coordinate of point P, added to the constant term c, and divided by the square root of the sum of squares of the coefficient of x and y of the straight line. So using this formula, we'll take the absolute value, and in the numerator, we'll start considering the coefficient of x of the directrix. So that's 1. 1 will get multiplied to the x coordinate of point P. So that's 1 times h. That's h. Added to coefficient of y of the directrix line. So that's 1 as well. So 1 will get multiplied to k plus the constant term. So that's 1 whole divided by the square root of. Now we take the coefficient of x and y, square it and add it to each other. The way 1 squared added to 1 squared. Now, to simplify this, what we'll do, we'll square both sides, and that's going to give us h minus 1 whole squared plus k minus 1 whole squared equals to, we have h plus k plus 1 whole squared divided by, so we have square root of 2, squaring it gives us simply 2. Now, we're going to simplify this, and that's going to give us h squared plus k squared minus 6h minus 6k minus 2 times hk plus 3 equals to 0. Now we are almost done. Now finally what we'll do, we'll replace the value h with x and the value k with y. So that's going to give us x squared plus y squared minus 6 times x minus 6 times y minus 2 times xy plus 3 equals to 0. And this is going to be the required equation of the parabola, whose focus is at the point 1, 1, and the equation of the directrix given by x plus y plus 1 equals 0.